going to take a few minutes to show you how to use the Process Disturbance Analysis feature of the Loop Analyzer. The Process Disturbance Analysis tool is a means to determine the root cause of process disturbances such as oscillations, upsets, or other types of disturbances in the process. To create a process disturbance analysis, you right-click in the PDA Analysis tab and select New Analysis. Give the analysis a name. I'll say all loops for this one because I'm going to use all the loops. Click OK, and a wizard will pop up and it will take you step by step through the process. First step is to select the loops. In this case, I'm going to select all of the loops by shift clicking and moving them over here. You can use the filter at the top or select individual loops to restrict the loops involved. For example, if you know all of the loops are in one process area, you can select that area, likewise for some of the other options. In this case, we're using all the loops. We click Next. What we're going to see then is an overview of the time series, just to give you an idea of the loops we're analyzing. Some loops may be excluded if their compression is too high. Compression is typically an artifact of historians if you're getting the loop data from the process historian rather than directly from the process. It can also be from a process filter that's doing too much filtering. We don't want to include compressed data simply because it may throw off the analysis, so we'll exclude those loops. Next step shows you power spectra. If you know the range of frequency that you're interested in, you can use low pass, high pass, or band pass filters to restrict the analysis to that range. If you don't, you can simply leave it alone as I am and simply use the entire frequency range, which we'll do in this case. Click Next. We've already calculated now some clusters. We've got an oscillation cluster, which is calculated based on the frequency spectra. We view by power spectrum. It makes it easier to see. We can see that yes, these loops do have very similar power spectra with a peak at about 160 seconds. Likewise for the other two oscillation clusters. The other types of clusters, PCA clusters, are principal component analysis clusters. They use a different technique. The math involved is more complex than I'm able to explain, but there are papers available if you're interested in that. The frequency spectra in this case looks similar for the two loops within the cluster, but that's not how the actual cluster is calculated. If you look at the other two PCA clusters, you can see the signals have a similarity when looking at the time series, and that may or may not show up in the frequency band. Here you can see a bunch of humps that seem to be related. If we look at the power spectra, some related, some aren't. So it's a different technique. Finishing, just click OK. On an oscillation cluster, if we go to the PDA Analysis tab after we're done with the wizard, we can look at nonlinear root causes, which is the most common thing to look at for oscillation clusters. And nonlinearity is used as a means to determine the root cause. The process may act as a filter. So, for example, if you have a square wave, as it moves through the process is typically going to filter it out, so it becomes more like a sine wave. That's an oversimplification, but in general, the more nonlinear the signal, the more likely it is to be upstream or a contributing factor rather than something that's being caused by something else. You can also calculate time delays and look at the time delays causalities. Basically, causalities are primarily for PCA clusters, but time delays show you the time delays in the signal, so one signal to the other. And so that information may be useful. Typically, the results would be combined with the study of a process diagram or your knowledge of the process to help give you some insight into where you might look to find the actual root cause. It may be stiction on one of these controllers, or it could be something else, but in general, that's how you use the PDA analysis tool.